So here we want to be able to evaluate the definite integral. And the integral that we have is the cosine of pi t divided by 2 times dt, with the lower limit of 0 and the upper limit of 1. So the first thing we're going to do is we're going to use our u substitution. So we're going to let u equal pi over 2 t. And so now we're going to take the derivative of both sides. So taking the derivative of both sides, we're going to get du, which is equal to pi over 2 dt. So what we're going to do is we want to be able to substitute back in for the dt, so we're going to have to divide both sides by pi over 2. So dividing by both sides by pi over 2, we're going to get the reciprocal, which is 2 over pi du, which is equal to dt. Okay, so let's go ahead and rewrite our original question. So we're going from 0 to 1. The cosine of pi t over 2 dt. And now let's go ahead and put in our substitution. So we have the cosine of u, and we know that dt is equal to 2 over pi du. And now we need to change our upper and lower limits according to u. Well, we know that u is going to equal pi over 2 times 1. And down here, u is going to equal pi over 2 times 0. So let's go ahead and continue. So now we have an upper limit now of pi over 2 and a lower limit of 0. We have the cosine of u, and then we're going to factor out the constant 2 over pi times du. Okay, so now we're going to go ahead and then take the antiderivative of the cosine of u. And so the antiderivative of the cosine of u is sine u. So we're going to have 2 over pi times the sine of u. And we're going to evaluate it from the upper and lower limits of 0 and pi over 2. So let's go ahead and put that in. So we're going to factor out the 2 pi. And so then we're going to take the sine of pi over 2 and then subtract the sine of 0. So we know that the sine of pi over 2 is equal to 1. So we have 2 over pi times 1 minus the sine of 0 is 0. So we end up getting 2 over pi times 1, and therefore our answer is going to be 2 over pi.